Continuing with the GeneralFoundry problem, we have data now for the PERT analysis. To do that, we need 3 additional estimates of time. We need an optimistic time, in other words, our best guess, a most likely time, perhaps we have some experience at this, so we have an average sense of what it should take, and a pessimistic time, our worst case scenario within reason. It has to be something that is not an outlier to this process, but a pessimistic time. We'll use that then to calculate the expected time. I use these headings when I do this. Recommend that you put them in. Without this, I put in these equations here to help you. They're from the textbook. They're the equation to calculate expected time, the equation to calculate the variance, and the equation to calculate the standard deviation, which is simply the square root of the variance. So let's go ahead and enter in our activities. We have A, D, E, F, G, and H. The same predecessor setup. A and B do not have a predecessor. C is preceded by activity A and B for D, C for E, C for F, D and E for G, and F and G for H. Always determine, even though we know, it's a good habit to get into, determine the number of n nodes. We look at our predecessors. We see that we have A, B, C, D, E, F, and G. The only activity that does not precede another activity is activity H. Therefore, it is the n node. Now we will enter the times that we've been given. You may want to pause the video at this point. Once you have the times entered, we'll use the equation above to calculate the expected time. The expected time is the quantity of the optimistic time plus 4 times the most likely time plus the pessimistic time all over 6. You can see that we have 1 optimistic time, 4 most likely times, 1 pessimistic time, totaling up to 6. So we divide by 6. This is just a weighted average, weighting the most likely time 4 times heavier than the optimistic time and the pessimistic time. Therefore, we divide by 6. It's the same in every instance, so we'll just copy that down. The variance equals the pessimistic time, the largest value, minus the optimistic time, the smallest value, divided by 6 raised to the 2nd power. Take some of those ones out of there. So we take the range of times, the largest from the smallest gives us the range. We place it over 6, and in this case, the 6 indicates a 99.9% confidence interval, 3 standard deviations on each side of the mean. So 3 and 3 is 6. If you wanted a 95% confidence interval, you would, instead of 6 there, you'd put 3.289, whatever 2 times the standard deviations for a 95% confidence interval was. If you wanted a 90% level of confidence, you'd put something in the area of 2.56 in that range to get a 90% confidence level in the model. This model with a 6 will yield a 99.9% level of confidence. And it's the same for everyone all the way down. The standard deviation is simply the square root of the variance. There we go. Now we'll go ahead and do our forward pass and backward pass just as with any of the other models. We have an earliest start time for an activity with no predecessor is 0. The earliest finish time is going to be the start time plus, and then we're going to use the expected time. That's why we calculate the expected time. Again, the earliest start time for an activity with no predecessor is 0. The earliest finish time is the start time plus the expected time. And that's the case all the way down on the forward pass. So I'll just copy that, and as I fill in the earliest start times, the earliest finish times will update themselves. Activity C is preceded by activity A. So the earliest start time for activity C is the earliest finish time for activity A. Activity D is preceded by activities A and B. In the forward pass, we use max. Both activities have to be completed before activity D can start. So we take the max of activity A and B, of activities A and B. Activity E is preceded by activity C, so the earliest start time for activity E is the earliest finish time for activity C. The same with activity F, looking up here to activity C. Activity G is preceded by both activities D and E, so it's the max of the finish times of activity D, activities D, and activity E. Same with H is the max. In this case, it's preceded by activities F and G, so it's the max of activity F, comma, G. All right. We have one end node, so the finish time for our project, the latest finish time, earliest finish time, equals, always do that, don't type it in, equals, point to that value. Now, if we know the finish time for the activity, we can calculate the start time. We can take the finish time and reduce that by the expected time of the activity, and that will yield our start time. And that's the same all the way up. So I'll just copy that up to there. And as I complete these, then the latest start time will update itself. Now, I'm on activity G. I'm on activity G, so I look in the predecessor column and I see what activities activity G precedes. It precedes only activity H. So since G has to be finished for H to start, and since H started week 13, we conclude that G finished week 13. I am on activity F. Activity F, I find activity F in the predecessor column. It precedes only activity H. So again, the latest finish time for activity F is the latest start time for activity H. I am on activity E. Activity E, I look down here, it precedes only activity G. So I'll point that to the start time for activity G, and that's the finish time for activity E. I am on activity D. D precedes only activity G. So again, I'll point this to activity G's start time, and that becomes the finish time for D. Now I'm on activity C. Activity C precedes both E and F. I'm on the backward pass, so I use the minimum of the start times for activities E, comma, F. All right. I am on activity B. Activity B precedes only activity D, so the finish time for B is the start time for D. Now I am on activity A. Activity A precedes both activities C and D. The min on the backward pass, the start times for activities C and D. Now calculate the slack. The slack is calculated by subtracting finish times or by subtracting start times. It doesn't matter. I usually subtract finish times, and I begin with the latest and subtract it from the earliest. And that goes all the way down. Critical path, again, I set those equal to 1. If it's critical, use the if statement. If the value to my left, the slack, equals 0, then 1, otherwise 0. All right. That's the same. I copy that all the way down. Now I can calculate my critical path by looking. And the critical path is A, C, E, G, H. The project length is always found here in the latest finish time for an end node. The project variance. The project variance equals the sum of the variances for the activities on the critical path. That's one of the reasons I use a 1 here. It allows me to use the sum if function. So if this changes, sum if, here's my range. I'm going to look down the critical path. If there's a 1, then I'm going to go over to my variance column and get that value, add them together. Sum if, look to my critical path column. If there's a 1, it means that activity is on the critical path. Then go to the variance column, take the variance for that activity, and add it up. That gives me a variance of 3.11. Project standard deviation, about the only way to get the standard deviation. You can't add the standard deviations for the activities on the critical path and get the right answer. The only way to arrive at the standard deviation is to remember the relationship between the variance and the standard deviation, and that is the standard deviation is always the square root of the variance. So we have the variance, we'll take the square root of the variance, and that will give us the standard deviation. Okay, now In the text, we're asked to determine the probability of finishing the project in less than or equal to 17 days. We use our normal distribution function in Excel, norm dist. And the norm dist prompts us for 4 items. It wants an X value. The X value is the length of time in days, in this case, that we're looking for, and that's 17. We're wondering about finishing in 17 days. We have a mean, and that's the project length in PERT. It asks now for a standard deviation. We've calculated that. And of course, this is a continuous distribution, so we're going to answer true to get the cumulative. Press enter. And there is the probability of finishing in less than or equal to 17 days, 87%.